Now in lexical analysis we will see the topic called regular expression direct DFA method. So in direct DFA method they will be giving a regular expression. For example, we take a regular expression A or B the whole star followed by A, B, B. Right? So while constructing the direct DFA method, the first step in constructing a direct DFA method is that we have to construct the syntax tree for a given regular expression. So and after that, after constructing a syntax tree, we have to find the four methods. That is, first we have to find the nullable of a particular node, and then we have to find the first position. Next we have to find the last position of a node, and then we have to find the follow position of a node. Right? So after finding all these four, we have to consider after finding these four options, right? So we'll getting a value, and then based on that we'll be constructing a direct DFA method. So first we'll be constructing the syntax tree. So for constructing a syntax tree, so we have to find the augmented for a given regular expression. So augmented grammar is that we have to take a regular expression A or B the whole star followed by A, B, B. And for in augmented grammar, we'll be adding an hash symbol at the end of your productions. So after adding the hash symbol in your given regular expressions, you'll be assigning the rule number for a given terminal nodes. So 1, 2, 3, 4, 5 and 6. After assigning the rule number for a given productions, we have to construct the syntax tree. So while constructing the syntax tree, so we have to construct the syntax tree for A or B the whole star first. So for finding the constructing the syntax tree for A or B, A, D will be your leaf node, and then OR operator will be your child root node, and the child node will be A or B. And then A or B the next we have to construct it for star. So A or B the whole star. So star will be the root node. So for star operator will have only one node, one leaf node will be having. So after the star we have a dot operator, concatenation operator, dot operator, and followed by we have A. So root node will be a dot operator, then star, and the another leaf node will be A. So and after that A followed by A we have a dot operator, and we have B. So again dot, we have B, and then after B we have another dot concatenation operator. So dot, we have B. Okay. So and after B we have hash symbol in the augmented grammar. So we have hash symbol. Right. So and then we have to give the rule number which are given in the augmented grammar. So 1, 2, 3, 4, 5, 6. Right. So and then we have constructed the syntax tree for the given regular expression. So next we have to find the nullable value for a particular node. So when finding the nullable value first position and last position, we have some rules, right? So for if your leaf node will be an epsilon, if your leaf node is an epsilon, your nullable value will be true. If your leaf node is epsilon, your nullable value will be true, and the first position and the last position value will be null. So if your leaf node is either terminal symbol, any other terminal symbol, whether it's an A or B or whatever it is, and your nullable value will be false, and your first position and last position will be I. The position value will be I, right? So and then the next will be going for your OR operator. So for OR we'll have C1, two nodes C1 and C2 we have. For OR operator we have two childs, in which for OR operator we have for finding the nullable position, nullable of C1 or nullable of C2. If your nullable of C1 is false and nullable of C2 is false, false or false is false. So based on that we will be determining it. Right? So and for finding the first position, your value will be first position of union, last position of that particular node. So and for last position also, last position of C1 union last position of C2. So next for dot. So for dot operator we have, for dot we'll have C1 and we'll have C2. So for finding a nullable value of dot operator, so nullable value is nullable of C1 and nullable of C2 will be a nullable value for a particular node. And for finding a first position and last position we have rule. So if your first position of C1 is true, means if nullable of C1 is true, we will be having it as first position of C1 union first position of C2. If your nullable of C1 is false, then automatically your last position of that particular C1 will be your answer for your particular node. So same for it's a replica of your last position of value. So now based on this all these four rules, we will be constructing your syntax tree again. So for constructing this here now leaf node is 1. So that is that leaf node we have some terminal values. So we have a position here. So nullable of that particular leaf node it's a terminal symbol. So nullable value will be false. Right? So and then for this also your nullable value will be false, and then for we have to find the first position of this. So it's a false, nullable of C1 is false, and it's also a terminal symbol. Then first position will be that I value. So here I is 1, so the position is 1, so we are giving it as 1. So and for finding the last position also here 1, and for this B node also we have to find out. Here position is 2, it's also a leaf node. So then leaf node is I, so here position in I is 2, so first position is also 2 and the last position is also 2. And after that we have to find for this star OR operator. So for finding your OR operator, nullable of C1 is what? Now false. Nullable of C2 is false. Now false or false is false. Okay. So and then now we have to find the first position of this OR operator. So for first position of your OR operator is nullable of that is your first position of nullable of C1 is false, means you will get it. Your answer is first position of C1 union first position of C2. So first position of C1 is 1 and then first position of C2 is 2, so that you will be getting your answer is 1, 2. And then so for last position also, for last position of C1 union last position of C2, since your C2 is false, right? So next we have to construct for star operator. So star operator will have only a particular one node. So the nullable value of your star operator is true, so we will have true, and then the first position is only one node we have, so the first position of C1 will be the answer for this top root node. So we will have 1, 2, and here also we will have 1, 2. And then next we have to find it for the dot operator. So finding a dot operator, we have find the C1 node, and for C2 node we have to find out. Now C2 is a leaf node. We have assigned a position is 3. So the nullable of C1 is false, right? So and then we have to find the first position. So first position value is position is I. So here we will be giving it finding the value as first position of C2 is 3. So you are getting 3, and last position is also 3. Now we have to find this for dot operator. So first position of C1 is true now. So if it is true, the answer will be first position of C1 union first position of C2. So you will be getting answer is 1, 2, 3 you will be getting. And for finding the last position, you will be getting the value as first position of C2 is false, then automatically your answer will be 3. Okay. So and then we have to find the nullable value. So true and false is, now the answer is false, so we will be giving it as false for the nullable positions, right? So and then next we have to find it for this dot operator. So this dot operator we have to, before finding this we have to find the leaf node. So here also we are given the question is 4, so it's a leaf node, then the nullable value is automatically we have it as false, right? So and then here now we have to give the find the first position. So first position value will be 4, since your position is 4 and then the value is I, so here we will get a 4 for the first position and last position. And next we have to find it for this operator. False and false is, we will get it as false nullable value, and we have to, for finding the first position, here first position C1 is false. If it is false, then automatically the answer will be 1, 2, 3. The first position of C1 will be your answer, and for finding the last position we have to take the null value. So null value is defaulting false, and the C2 is value is false, so that the last position will be your answer. So here the answer will be 4. So and then next we have to find the production the nullable value and first position last position for this leaf node. Here it's a leaf node, so it's false, and then the position index is position is 5, so then first position will be 5, and here also it will be 5. And then now we have to find the dot operator nullable value for this dot operator. So dot false or false is false, and then we have to find the first position and all constant, same for this remaining which we have seen. So here nullable of C1 is false, so then automatic answer will be 1 comma 2 comma 3. Right? So and then next we have to find the last question of this node, and the last question is here it's false, and then answer will be 5. So and then next we have to find it for leaf node. Here leaf node is false, and then the position is 6, so you'll be getting answer as first position of C2 as 6 and last position of C2 as 6, and then we have to find the dot operator. Next nullable value of this dot operator is false, since C1 is also false, C2 is also false, false or false is false. So now we have to find the position, first position and last position for this particular regular expression for the top root node. So here it's false, and if nullable of C1, it will be your answer, so that 1 comma 2 comma, and here for the last question it's false, so an automatically answer will be 6. So now we have constructed the syntax tree based on nullable, first position and last position. So and then the next step is that we have to find the follow position. For finding a follow position, we have two rules. One, for a star operator. So star will have only one node, that is we'll say it as C1. Yeah. So this C1 will have first position here, last position here. So here is the trick which I am going to apply this is that, so each and every last position will be a follow of this first position. So if you are having it as 1 comma 2 comma 3, so now we have to we can take our example. We have node, this is follow position of particular node. So we have 6 nodes, 6 positions, 1 2 3 4 5 and 6. We have 6 positions. So now for finding this, we have to find it for star as well as dot. For follow position we have only two rules, one is star and another one is dot operator. So first we will see it for star operator. So for each and every last position there will be a follow of your first position. So here last position of here only a star operator is there, that this will be a star operator, this one. So for this star operator this will be your C1, so this will be your C1 now. So in this C1 this will be your first position, this is first position and this one is last position. So for each and every last position there will be a follow. So for 1 the follow is 1 and 2, so here we have to write it as 1 comma 2, and then for this 2 it's a follow is 1 comma 2. So for 1 also, for 2 also we have to write it as 1 comma 2. Okay. So this is the rule for concatenation operator, and then next we have to see it for dot operator. So dot operator we have two nodes, one we have as C1 and then one we have as C2. Right? So for C1 also we have first position, last position, and we also have first position and last position. We will be eliminating this first position and last position, and same as your dot operator. So for each and every last position there will be a follow for a first position of C2. So now we have to see that how many dot operator are there in our given problem. So we have 1, 2, 3 and 4. We have for all the 4 we have to find the follow position of this dot operator. So for this dot operator this will be a C1 and this will be a C2. So this we'll say it as C1 and this we'll say it as C2. And now we eliminate this one and this one. Now this is the last position and this is the first position. I said before itself, for each and every last position there will be a follow of a first position of that next node. So for this one there will, its follow is 3. So for 1 follow is 3, and then for 2 follow is 3. And now we have find it for this node, and next we have to go for this node. So and then this is C1 and this node we will say it as C2. And now we have to see this, we have to eliminate this and this. This is last position and this is first position. So follow of 3 is follow of 3 is follow of 4. Okay. So and then now we have to see it for this node, and this for this node this will be a C1 and this will be a C2. So for this C1 this is 4. So this is first position, last position, and this is first position, last and first. We have a direction like this. And for 4 that is its follow is 5. So for 4 it's 5. So next we have to see it for this one, and for finding this node, this will be a C1 and this will be a C2, and for the last position, first position for follow of 5 is 6. So follow of 5 is 6, and for 6 it's a last node, so there will not be any follow position, just we have to assign it as hyphen symbol. So and then after completing this all these 4 process, now we have to construct the direct DFA method. This top root node value will be here A. Okay, so we have to take A as 1, 2, 3. Now based on this A, we have to pass a terminal symbol to this transition. So the transition of A comma A and the transition of A comma B, we have to see that.